This is NSAA 2021, Section 1, Question 55. So this question gives us a reaction. We have methane plus water going to carbon dioxide and hydrogen. We also have this table filled with different bonds and the relative bond energies associated with them. And we have to find out what is the energy change for this reaction. So how are we going to calculate this energy change? Well, we need to calculate the amount of energy it takes to break the bonds in our reactants and then the energy to form the bonds in our products. So if we start with breaking the bonds, what bonds do we have to break? Well, if we draw out the molecules for our reactants, here we have our methane and here we have our 2 moles of water. So let's look at the bonds. We have 4 CH bonds. So if we look to CH here, it's 430. So that's 4 times 430 would give us an energy of 1,720. And we also have 4 OH bonds from our water molecules. So that's 4 times 460, which is 1,840. So we add those together, we get 3,560. And because breaking bonds is an endothermic process, this is going to be a positive value. So now let's do exactly the same but for making our bonds, which we know must be exothermic if the other is endothermic. So what bonds do we have? Well, here we have our carbon dioxide and our 4 molecules of hydrogen. So for our carbon dioxide we have 2 C double bond O, so that's 2 times 800, or negative 1,600 because it's exothermic, we need that negative sign there. And for our hydrogen we just have 4 lots of HH bonds, which is 4 times 440, or minus 1,760. So if we put those together, we get negative 3,360 kilojoules per mole. So now we have our making bonds and we have our breaking bonds, we just need to combine them together. So our total overall energy is going to be 3,560, take away 3,360, which is positive 200 kilojoules per mole. And that leads us to a final answer of A.